All right, let's get some practice with L'Hopital's rule. So again, if I recognize, like, if I look at the numerator and denominator individually, right, this individually would approach infinity, and then this individually would approach infinity as well. So I get the indeterminate form infinity over infinity, okay? So once I recognize I have that indeterminate form, I can use L'Hopital's rule and say that this is equal to the limit as x approaches infinity of, and then take the derivative of the numerator, or differentiate the numerator, 2x over 2x minus 2, okay? And here again, I kind of think about the limit of the numerator and denominator individually. I'm not applying the limit laws, I'm just kind of thinking about them individually. The numerator would go to infinity, denominator would also go to infinity. So, okay, I can say then by L'Hopital's rule, and I just put this little LH over the equal sign to indicate I'm using L'Hopital's rule, that this is equal to the limit as x approaches infinity of derivative of the numerator, 2, and I differentiate the denominator, 2, and this is equal to 1. Same thing as what we found before. Okay, and in fact, if I go forward with this next one, this is when L'Hopital's rule comes in really handy, because again, I'm thinking that if I look at the limit of the numerator only, as x approaches 1, I would get 0, and denominator only, I would get 0. So then, if I use L'Hopital's rule, oops, let me get my notation right, equals with an LH over it, limit as x approaches 1 of a times x to the a minus 1 all over b x to the b minus 1, okay? And now when I look at the limits of each of these, right, I can do the limit of the first one and I just get 1, or sorry, a, and then the denominator I would get b. So I can get that. So that's kind of interesting. Okay, here are a few more examples. You have the ideas. I want you to try each of them, and also I'll just comment that L'Hopital's rule does apply with one-sided limits and limits at infinity as well. So try L'Hopital's rule, verifying that you have an indeterminate form first, and resume the video when you're ready to see the solutions. And here are the answers. Okay, just kind of running through these. For the first one, I verified that it was indeterminate form of 0 over 0. Okay, so then I differentiated, and when I simplified it, I got tangent of x, and so then I just had to use the graph of tangent, recognizing that at pi over 2 from the right side, it goes to minus infinity. For this next one, you actually have to do L'Hopital's rule like 3 times, because you keep getting infinity over infinity, and when you finally whittle it down, you end up with e to the u over 6, and that just approaches infinity. Okay, then last one is kind of a hallmark that students in this section, they think, oh, okay, I just always need to use L'Hopital's rule. No, okay, you do not always need to use L'Hopital's rule. Try to use normal limit properties, okay? So for this one, there isn't a quotient, so it was hard to figure out how to apply L'Hopital's rule in the first place. But if we think closely, this x that's in the numerator could be represented as 1 over x, okay, in the denominator. And then in this form, I recognize, okay, I have sine of something over 1 over x, and that 1 over x appears inside sine. But I remember that there's that limit property, limit as x, or as theta approaches 0 of sine of theta over theta, that's equal to 1. So that was the idea that I was trying to use, okay? So if I manipulated this a little bit, I had to multiply by pi over pi, and then I was able to say, okay, there's an extra factor of pi, but I still have that sine of pi over x over pi over x. And then I just did a little bit of variable redefining. T is equal to pi over x, and then as x went to infinity, t went to 0. Okay, and then I just used that property where I said, okay, this is going to be pi times sine of t over t. That is going to be 1, so it's just 1 times pi, or pi. Okay, so we got some practice with L'Hopital's rule by verifying a certain indeterminate form. We're going to get more practice in the upcoming video, but big takeaway from this one is, yes, you can use L'Hopital's rule. You don't always need to.